In the world of 3D printing, few technologies capture the imagination quite like resin, or stereolithography, SLA, printing. Its ability to render astonishingly intricate details, smooth surfaces, and high-resolution models is unmatched by other desktop methods. Imagine miniature figures with individual strands of hair, or architectural models with razor-sharp edges. The promise is clear: unparalleled precision and beauty. However, unlocking this potential isn't always straightforward. Many beginners, and even experienced hobbyists, encounter frustrating failures, warping, or loss of detail. Achieving truly perfect prints demands a deeper understanding, a mastery of several interconnected elements that, when combined, transform possibility into stunning reality. This video will guide you through these crucial secrets, step by careful step. Our first secret begins with the very material itself, the resin. Resin, in the context of 3D printing, is a liquid photopolymer that cures, or hardens, when exposed to specific wavelengths of ultraviolet, UV, light. Not all resins are created equal, and understanding their differences is fundamental. We primarily encounter standard, tough, flexible, and clear resins. Standard resins offer excellent detail but can be brittle. Tough resins are engineered for durability, sacrificing a tiny bit of detail for strength. Flexible resins, as the name suggests, allow for bends and compression. Clear resins aim for transparency. The type you choose directly impacts the mechanical properties and visual finish of your print. Selecting the right resin for your project is your initial, crucial decision. Beyond simply choosing the right type of resin, consistency within that type is paramount. Think of it like baking: even with the best recipe, inconsistent ingredients lead to unpredictable results. High-quality resins from reputable brands offer reliable chemical composition, consistent viscosity, which is its resistance to flow, effectively how thick or thin it is, and predictable curing characteristics. Cheaper or inconsistent resins can introduce print failures, from bubbles forming during printing to uneven curing that leads to brittle spots or warping. Always store your resins properly, away from direct sunlight and in a temperature-controlled environment, as exposure can degrade their properties. A stable, high-quality resin is the bedrock upon which all successful prints are built. Our second secret delves into the microscopic world of layer height and resolution. Layer height refers to the thickness of each individual layer of resin cured by your printer's UV light. This setting is expressed in millimeters, with common values ranging from 0.025 mm to 0.05 mm. To put that into perspective, 0.025 mm is roughly 1/4 the thickness of a human hair. The smaller your layer height, the finer the resolution of your print, leading to incredibly smooth surfaces and exceptionally crisp details. Each layer becomes less noticeable, blending seamlessly into the next, much like tiny brushstrokes creating a detailed painting. This meticulous layering is what truly distinguishes resin prints. While finer layer heights, like 0.025 mm, deliver superior detail, they also significantly increase print time. Each thinner layer means the printer has to perform more individual curing cycles, extending the overall duration of the print. So, choosing the optimal layer height involves a critical trade-off between detail and speed. For highly detailed miniatures, jewelry, or display pieces where every micron counts, 0.025 mm might be ideal. However, for functional prototypes or larger models where speed is more important than absolute perfection in surface finish, a 0.05 mm or even 0.1 mm layer height could be perfectly acceptable. The perfect print considers the purpose of the model. Sometimes, a slightly thicker layer is the right choice. Our third secret, often overlooked but absolutely critical, is the intelligent use of supports. In resin 3D printing, models are built layer by layer from the bottom up, gradually being pulled out of a resin vat. Because new layers are always curing on top of previous ones, any part of your model that floats in midair or extends outwards without direct support from the layers below it will fail. These are called overhangs or islands. Supports act as temporary scaffolding, providing a structural base for these delicate features during the printing process. Without them, these unsupported sections would simply deform, sag, or detach, ruining your entire print. Proper supports are the silent heroes of successful resin prints. Beyond simply knowing why supports are needed, how you place them is a true art form. Strategic support placement is about balancing structural integrity with minimal post-processing. You want to support critical overhangs and isolated islands sufficiently, but you also want to avoid placing supports on highly visible surfaces if possible, as they can leave small marks. Often, orienting your model at an angle can significantly reduce the number of supports required and minimize contact points on critical areas. Software tools help automate this, but manual refinement is key. Learning to read your model for potential failure points and proactively adding supports is a skill honed through experience. The effectiveness of your supports isn't just about where they are, but also their angle and density. Support density refers to how many support structures are clustered together in a given area. For delicate or heavily overhanging sections, a higher density of supports provides greater stability. However, too many supports can make removal difficult and increase the risk of damaging your model's surface. The angle at which supports connect to the model, and to the build plate, also plays a role in their strength and ease of removal. Steeper angles can be stronger but harder to remove cleanly. It's a delicate dance of engineering, ensuring enough strength without creating an unmanageable mess that detracts from the final piece's perfection. Finally, the thickness of the support tips, where they actually touch your model, is crucial for clean removal and minimal scarring. Thicker tips provide more robust support but leave larger marks. Thinner tips leave less noticeable marks but can be too weak, leading to print failures. Finding the optimal tip thickness often involves experimentation, balancing reliability with the aesthetic quality of your finished print. After printing, careful support removal is an art in itself. Using flush cutters or nippers, slowly and precisely snip away the supports. Taking your time, and even warming the print slightly, can make supports more pliable and less likely to rip chunks out of your carefully crafted model. Patience here prevents last-minute heartbreak. Our fourth secret ensures your print has a solid beginning: platform calibration. Specifically, Z-axis leveling. The Z-axis is the vertical axis along which your build plate moves up and down. For successful resin printing, the build plate must be perfectly level and parallel to your printer's LCD screen. If the Z-axis is even slightly off, your first layers might not adhere evenly, or they could cure too thick or too thin on one side. This often leads to failed prints, warped bases, or parts detaching mid-print. Proper Z-axis leveling is like ensuring a foundation is perfectly flat before building a house. It sets the stage for stability and success. Follow your printer's specific calibration instructions precisely. Closely related to leveling is ensuring proper adhesion of your initial layers to the build plate. The first few layers, often called burn-in or base layers, are crucial. They need to stick firmly to the build plate so the rest of your print has a secure anchor. Several factors influence this. A meticulously clean build plate, free of any resin residue or fingerprints, is essential. Also, your initial exposure time for these base layers is typically longer than subsequent layers, ensuring a stronger cure and better grip. If prints repeatedly fail to adhere, double-check your leveling, clean your build plate thoroughly, and consider slightly increasing the base layer exposure time. A strong start prevents a wobbly finish. Our fifth secret controls the very process of curing: exposure settings. This refers to the duration each layer of resin is exposed to the UV light from your printer's screen. The UV light's intensity, or brightness, and the precise timing of this exposure are paramount. Overexposure, where the resin cures for too long, can lead to a loss of fine detail. Blooming, where light bleeds beyond the intended layer boundary, and brittle prints. Conversely, underexposure, where the resin doesn't cure enough, results in soft, gooey layers, print failures, or prints detaching from the build plate. Finding the Goldilocks zone for exposure is critical for achieving crisp details and structural integrity. Dialing in the correct exposure time is not a one-size-fits-all solution. It's a dynamic variable influenced by your specific resin, the model of your printer, its screen's age and intensity, and even your ambient environment. Therefore, performing exposure calibration prints is essential. These small test prints, often with a series of tiny features, allow you to fine-tune your settings to achieve the best balance of detail and strength. It's a process of iterative experimentation: print, examine, adjust, and repeat. Many online communities and resin manufacturers provide recommended settings, but these are merely starting points. Your perfect print journey will involve finding the unique exposure settings for your setup. Once your print is finished, the journey to perfection is far from over. Post-processing is a vital series of steps. The first is the isopropyl alcohol (IPA) wash. After printing, your model will still be covered in a sticky layer of uncured, liquid resin. This must be thoroughly removed. IPA dissolves this excess resin, revealing the true details of your print and preventing a sticky, greasy surface. Using 2 baths, a dirty bath for the initial rinse and a clean bath for a final wash, ensures comprehensive cleaning. Agitate the print gently or use a wash station. Safety is paramount. Wear gloves, work in a well-ventilated area, and properly dispose of resin-contaminated IPA. After the IPA wash and ensuring the print is completely dry, the next critical step is final UV curing. Although the print appears solid after printing and washing, the resin is not yet fully hardened throughout. A final, controlled exposure to UV light ensures the resin achieves its maximum strength, hardness, and durability. This process is called post-curing. You can use a dedicated UV curing station, a nail lamp, or even natural sunlight, though the latter is less controlled. Proper post-curing prevents your prints from remaining soft, warping over time, or developing sticky surfaces. It solidifies the internal structure, making your detailed model robust and ready for its intended purpose, be it display or function. For truly perfect, display-quality prints, especially those that need to be exceptionally smooth or transparent, polishing becomes the final secret in post-processing. Even with careful support removal and optimal layer heights, tiny imperfections, support marks, or faint layer lines can remain. Polishing involves a meticulous process of sanding, starting with higher grits and progressively moving to finer ones, followed by buffing with polishing compounds. For clear resins, this step is essential to achieve optical clarity. This is where a print transitions from merely successful to truly exquisite. It's a time-consuming step, often reserved for hero pieces, but it underscores the commitment to perfection that resin printing allows. Our seventh and final secret acknowledges the silent influences around your printer, the environment. Temperature plays a surprisingly significant role. Resin viscosity, how thick or thin the liquid resin is, changes with temperature. Colder resin is thicker, affecting flow, leveling, and even adhesion. This can lead to print failures, incomplete layers, or poor detail. Ideally, your printing environment should be stable and relatively warm, typically between 20 to 25 degrees Celsius, 68 to 77 degrees Fahrenheit. Using a small space heater or an enclosure can help maintain this optimal temperature, ensuring your resin behaves predictably and cures consistently, contributing significantly to a successful and perfect print. Beyond temperature, humidity and dust are other environmental factors that can subtly sabotage your prints. High humidity can sometimes affect the chemical properties of certain resins, leading to inconsistent curing or sticky surfaces. While less impactful than temperature, a moderate humidity level is generally preferred. More critically, dust is the enemy of pristine resin prints. Airborne dust particles can settle on your printer's FEP film, the transparent film at the bottom of the resin vat, or even directly into the liquid resin. These particles can then block UV light, creating tiny divots or imperfections on your print. Maintaining a clean, dust-free workspace, keeping your resin covered, and regularly inspecting your FEP film are simple yet powerful habits for achieving perfect prints. Achieving perfect resin 3D prints is truly an art, one that combines scientific understanding with meticulous practice. From the fundamental choice of resin quality to the fine calibration of layer height, the strategic placement of supports, precise exposure settings, thorough post-processing, and finally, managing your printing environment, each of these 7 secrets plays an indispensable role. They are not isolated steps, but interconnected facets of a holistic process. Mastery comes not just from knowing these tricks, but from understanding how they influence one another. Embrace experimentation, learn from your failures, and approach each print with patience and attention to detail. With these secrets in hand, you are well on your way to consistently producing stunning, high-resolution resin prints that truly impress.